This shows convergence east, true least. True north is out to the east of grid north. So convergence is defined as east. The grid heading is 105 degrees. Convergence east, true least. True should be 20 degrees less than grid. So the true heading should be 085, which it is, as we can see. This one shows convergence west, true best. True north is out to the west of grid north. So convergence is defined as west. The grid heading is 105 degrees. Convergence west, true best. True should be 20 degrees more than grid. So the true heading should be 125 true. Convergence follows the same pattern of conversion of direction as our previous conversions of true variation magnetic deviation compass. But note that it goes on the left-hand side of the columns if going from true to compass. So, to give an example, if the grid heading is 090 and the convergence is 10 west, then true will be 100. The rest fills in the familiar way. And, as you would expect, we follow the same rules when working from compass to true to grid. If the true heading is 100 and the convergence is 10 west, convergence west, true best. Then grid must be 10 degrees less than true, giving us a grid heading of 090. Now that we can convert from true to grid on the chart, we need to find a method of steering grid direction. This can be done using either a compass or a gyro, as we shall see in the next lesson. Let's summarize this lesson. It is the first of 3 lessons on grid navigation. It explains what it is and why we do it, and then explores the idea of convergence. The later ones will look at steering when using grid and the solution of grid problems. Grid navigation is used because, at high latitude, the amount of meridian convergence becomes significant and causes problems in defining and steering a direction. We use a grid and its associated grid north on our chart instead of latitude and longitude. And we also have to reorientate our compass or gyro. But we are able to define a constant direction for our straight line track. We choose one particular meridian as the datum. And from this we define our grid. We showed that our normal definition of chart convergence is also the difference between true and grid north at any point on the chart. So we can calculate the convergence by taking the change of longitude between the datum and any particular longitude on the chart and applying the normal rules, depending on whether it is a polar stereographic or Lambert's chart. Remember the rule EWWE to work out whether the sense of the convergence is east or west. Remember that convergence is east when true north lies to the east of grid north, and west when true north lies to the west of grid north. And remember, convergence east, true least, convergence west, true best. And finally, we showed that converting from grid to true follows the same simple rules as converting from true to compass, but note that the grid and convergence columns go on the left, if we are going left to right from true to compass. That concludes this lesson. We will study steering by compass or gyro when using grid next.